record. And this is Unit 2. Unit 2, Chapter 1. Before I get into Unit 2, Chapter 1, I hope you see that test number 1 is posted in Blackboard. That was a great test. 11 out of 22 people who took the test made A's. That's very good. 11 out of 22 made A's. But I saw that 2 people did not take the test because they said they were quarantined. I want to say this, that if you're quarantined, you still have to take the test. If you miss a test, the rule says I'll give you a 0. Okay, and maybe you did not know that. If you are quarantined, you still have to take the test online. All right, so I will just take it that you didn't know about that. And I'm going to post a retake. And I'm not just going to make it for those who are quarantined, because it's not fair to those who came in and took the test. I will post a retake. If you want to retake, I don't see how you can retake if you made a 95, because if you made a 95, you actually made more than 100. But say you made a 70 and you want to make an A, or you are among those who made 60s. All right, so I will post a retake, and I don't think I'll be doing it all the time. I am just going to post a retake, and it's going to be timed 90 minutes. And that retake will be tomorrow night. I'll make it night, you take it at home, but it's still going to be 90 minutes. It will not be the same test. Let me see what the question is. It will not be the same test. So let me see what the question is. Sorry, I'm late. Okay. Okay, we have 50. Okay, you're 50. All right. Okay. Now, let me say what I was saying again. Some people missed the test because one person said he didn't do well because he hasn't taken a test online before. All right. I just want to let you know that most tests are going to be online anyway. All quizzes will be online. So I will give you another chance to pass the test. So I'll post a retake tomorrow night, 90 minutes. So for whatever reason you have not to make a good grade, if you were quarantined so you did not take the test, being quarantined is not an excuse. You have to take the test. So I hope it doesn't happen again. So I will give you a retake, but another test if you were sick and for any reason, if you don't take the test, final exam will make it up for you. Okay, so there'll be a retake. We are missing about 8 people, but we have to start. Okay, is there any question that I need to know? Any question? What time tomorrow night? I will just make it a 90 minutes test. You can take it anytime, but anytime you take it, it's going to be 90 minutes. Because I don't know your schedule. So I just make it a 90 minutes test, and it's going to be posted tomorrow. So you have to take it tomorrow. All right? Can you start today night? Today? Okay. I can post it tonight. That way you have time to take it, but just know that it's a 90 minutes test. Whenever you start, after 90 minutes, it's going to stop you. That you haven't taken a test online before is not an excuse. So that is why I'm giving you another chance. Remember, 11 people made A's in that test, so you don't have any excuse. Last time it was supposed to be last week, and I postponed it to this week. I tried enough. I did my best for you. Okay, so let's quickly go to limits. Do we still have two trials? Yes. Within that 90 minutes, you can retake it. After 90 minutes, you are done. Zachary, did you hear my answer? Zachary? Okay. It's going to be a 90-minute test. If you finish it within 45 minutes and you want to retake it, good. But it's still going to be a 90-minute test. Okay, so let's start. And I am going to take a picture of those who showed up on this. And then that is going to be my, there are 16 of us out of 23. So I will take the picture and use it as attendance. Since you don't have any other question, let's start. I am going to start with PowerPoint, section 1.1, limits. And I'm not going to go through all the slides. We'll just go through a few slides, and then we go to a practice test, and we can go to today we are supposed to complete sections 1.1, 1.2, 1.3. Okay, so we do our best. Let's start from somewhere. So we are starting from 1.1. So what we are doing is limits. Limits. That is what we are doing. Question. Let me see what the question is. Then I will. What's the question? Do we still have to? What was the question? Okay. If you have any other question, I think I have answered all the questions that you have. Okay, so let's go back to that PowerPoint. Okay, so we're starting with limits. And so the objectives for this lesson is finding the limits of a function. The function can be linear, can be quadratic, it can be rational, it can be cubic, and it could be numerical limit. So we will soon see what numerical limit is, or graphical method of finding limits. And by the way, let me quickly draw on this section. Suppose I'm told to find numerical limits. And let me go here. If I'm told to find numerical limit, let's go to slide 3 and look at it. I want everybody to see that in this slide 3, that the letters A starts to increase from 2.24. The next one is greater. The next one is greater. The next one is greater. No matter what, actually, if I round it up, I have 2.2. Suppose I'm told to round it to 2 decimal places. It is 2.2 here, 2.2 here, 2.2 here. But you know what? If I consider all the decimals, it is increasing from left to right. So if numbers are increasing, numbers in a sequence are increasing from left to right, I can write it this way. Limit as x tends to 2.2 from the left. Do you see this small sign? 2.2, this is 2. So if you are asking a question, can you unmute and say it? Because that may be a question that I didn't see. Unmute and say what you want to say. Is there a question do I need to hear? Okay, this is supposed to be 2.2. Let me clean that and write it well. So the limit as x tends to 2.2 from the left. Why from the left? This sign here says from the left. It means that the smallest number is on the left-hand side, the highest number is on the right. But the important thing is that anywhere, it is increasing from left to right. Therefore, this is a left-hand limit, and this denotes left-hand limit. Limit as a variable unknown tends to 2.2. If you have a question and you are texting me, I am out of that, so you can unmute and say something. Do you have a question, anybody? Okay, I want you to look at this one also. This number is the highest number. I want you to look. It is increasing from the right-hand side up to this point. Therefore, B, I can write B, this one here. I can write it as limit as A, suppose it's A, tends to 5.51 from the right. Why from the right? Because it is increasing from the right-hand side coming here. So I want the emphasis today is on this. Look at this. The emphasis on this small sign, When there is a small sign negative, it means coming from the left. When it is the small sign is positive, it is coming from the right. Limit as x tends to a from the right. Limit as x tends to a from the left. Any questions so far? Before we start solving problems, I want us to know this. This is very important. So let's go to slide 4. This slide, I don't really need this because there are things you can do on your own. I just want us to see the basics here. So the definition, as x tends to a, the limit of the function is a number L written as limit of f of x as x tends to a is equal to a number. Okay? If all values of f of x are close to L for values of x, so that is what we are trying to say. So, but let me write a summary, a quick summary. If I'm told to find a limit, suppose I'm given that f of x is equal to 2x, and I'm told to find the limit as x tends to 2 of f of x, of the function f of x. Okay, so what I am told to do is actually find the left-hand limit and the right-hand limit. This question implies that I should look for left-hand limit, that's it, limit as x tends to 2 from the left. Also find the limit as x tends to 2 from the right. If both of them are equal and they are equal to a number, then the limit exists. If both of them are not equal, then the limit does not exist. So let's try it here now. Okay, so limit this function f of x, find the limit as x. So x tends to 2. And the important thing is that when x tends to 2, you have to try the left limit and right hand limit. Left hand limit and right hand limit. So let me try the left hand limit. I know that a number smaller than 2 is 1.99999. Smaller than 2. If I put it here, and if I draw this diagram, everybody, I will notice that the function is coming to the same point. Limit from the left and limit from the right. So they are going to be approaching the same number. Okay, you know what? Let's keep on going. So by the time we finish, you'll understand what we are saying. And we will do examples. We'll do examples so you understand. All right, so the limit of a function exists if the left-hand limit, I want you to watch watch that. Make sure you know that the left-hand limit has a negative on it. The right-hand limit and the left-hand limit are approaching the same number L. If both left-hand and right-hand limit are approaching the same number L, then the limit exists. Otherwise, it does not. Okay. Let's start. The most important. Let's start from here now. If this is a function f of x I used before is equal to 2x, this is a polynomial. The limit of a polynomial always exists. If I say as x tends to 2, even if I don't try the left-hand limit and right-hand limit and I do direct substitution, I just have 2 times 2 is 4. So the limit exists and the limit is 4. So I already know that the limit is going to exist because I can do direct substitution. I can do direct substitution whenever it is a polynomial. But if the function is a rational function like this, you really have to be careful. Because, okay, what is f of 3? If you plug in 3 in the numerator, you will have, let's bring it here. If I plug in 3 in the numerator, I have 3 times 3 is 9. 9 minus 9 is 0. If I plug in 3 in the denominator, I have 3 minus 3 is 0. And whenever you have 0 over 0, when you are calculating limit, you know it is called, it's a fallacy. It cannot happen. This is called the indeterminate form. The answer is never allowed to be 0 over 0. 0 over 0 is called indeterminate form. It does not make sense. So you have to do something. What is that something you have to do? You have to do what is called an algebraic manipulation. So whenever your direct substitution gives you 0 over 0, it means there is a common factor, there is a hole in the graph, which we talked about in Unit 1. And so we have to factor out the hole in the graph and take a limit. So let's do it right now. So I'm going to factor out the hole in that graph and take a limit. So I'm going to take off all this and factor out the hole in that graph and take a limit, because this is a rational function. It is not a polynomial. I can do direct substitution in any polynomial, but I'm not allowed to do it in a rational function unless it gives me, okay, so what I have to do is factor out the common terms. In the numerator, I have a difference of 2 squares, so I have x plus 3, x minus 3. In the denominator, I have x minus 3, which is the hole in the graph or the common factor, and so they can cancel out. So remember, you know this from the junior classes. You continue to use it. And therefore, after the factoring, you have a remainder x minus 3. So the remaining function is x minus 3. Now, f of 3 is 0 over 0. That is an eye-opener. It means that whenever f of 3, f of the variable or the a is 0 over 0, you must do some simplifications, algebraic manipulations. What is the limit of f of x as x tends to 3? Now we can take the limit right here. Take the limit, because you have factored out the common factor. And by the way, this is x plus 3, not minus 3. Okay, now that I take the limit, I have 3 plus 3. So my answer is 6. Therefore, the limit exists, and the limit is 6. The limit exists after simplification. The limit is 6. Okay, so don't remember that anytime you have 0 over 0, it is not allowed. You do algebraic manipulation. So this is called algebraic method of finding limit. Okay, sometimes you can be told to find the limit with a table. You can use a table to find limits. I want us to see as x tends to 3 from the left, all the numbers must be less than 3. But because you see that this is the biggest number, now you can say that, let me get another color. Now I can say that this is a left-hand limit. Of course, you see it here. It is a left-hand limit because it's coming from left to right. I'm looking for, okay, let me get it black. So it's coming from, it's increasing from left to right. So even though if I approximate here, I get 3. If I approximate here, I get 3. But this is the biggest. So it's approaching 3 anywhere. It is approaching 3 anywhere, but it starts from, so this is a left-hand limit because it's increasing from left to right. You must know the difference between left-hand limit and right-hand limit. You must, otherwise that's going to be a problem. Okay, next, you apply the left-hand limit. I mean, the right-hand limit. What happens here? Notice that from the right, this is 3. If I notice that this number is increasing, it's increasing from right until I get to this 4. Therefore, using the right-hand limit, it is tending to 7 here. Okay, so the most important thing is, thus it appears that both the left-hand limit and the right-hand limit are equal to 6. Left-hand limit and right-hand limit must be equal before you say that the limit exists.
Excuse
Okay,
me.
okay,
Uh,
go ahead.
I have a question. How are you? Do we get the bottom numbers of the f of x? So like the 5, 5.5, and the 7, 6.5, and all that. I'm confused on how we got those numbers.
This is not, they haven't actually, they started from here, so they wanted to start from 5, 5.5. They are trying to apply it, substitute in the function. They are substituting the function. So they substituted it in the function. And the most important thing, when you look up here, you see it is rounding up to 6, right? Do you notice that it's going to round up to 6 here, right? Do you notice this? And if you round up here, it's going to be 6. So the right hand limit is 6. The left hand limit is 6. But you know what? Using a table doesn't actually, the way we did before is the best way. No, did you understand how I did it this way? Did you understand this one?
Yes.
Okay. Well, this is better. This is better for me. Sometimes you don't have to use the table. This is easier and quicker. And you can explain. So this is better. And so if you get it this way, then we keep on doing it and you will understand it better. Okay, let's go to piecewise defined function. You will also see piecewise defined functions. You should be able to find the limit of a piecewise defined function. Okay, notice that the condition here is x is less than 1. The condition here is x is greater than equal to 1. All right, find the limit as x tends to 1. And this is the same as find the limit from the left. Find the limit as, let me write it, limit of h of x as x tends to 1 from the left, and see if it is it equal to limit as h tends to of x, the h of x, as x tends to 1 from the right. If they are equal, if they are both equal, then the limit exists. Well, let's see. We are going to try the limit from the left. But if it's a piecewise different function, it has a condition. I can only try left-hand limit here. I can only try left-hand limit for this piece. So let me try left-hand limit. So if I plug in 1.999 something, and well, no matter what, I'm going to have 2 times 2, 4 plus 2 is 6. So the left-hand limit will give me 6. 6. Left-hand limit, this one, will give me 6. Okay, let me try right-hand limit. If I plug, I mean, this is 1. Actually, 2 times 1. 2 plus 2 is 4, not 6. I'm sorry. I was doing 1, not 2. Okay, I want you to look at this. 2 times approximately 1 here. So let's say even if it is 1, it's going to be 2. 2 minus 4 is minus 2. The right-hand limit is not 4. It's actually negative 2. Question. Let me see if you understand. Are the left-hand limit and right-hand limit, are they equal? Are they equal? Somebody. Is 4 equal to negative 2? You can say something. Hello? Is there anybody there? Hello? Let me go back and see if you are, if I still have some, have you there.
4 is not equal to negative 2.
4 is not equal to negative 2. The left-hand limit and right-hand limit are not equal. Therefore, the limit does not exist. Limit does not exist. Okay, what I'm going to do, this is 1.1 only, and so on. So what I'm going to do now is let's read the sum. By the way, let's go back. I'm not going to intend. By graphing, we have already seen algebraic method. We have seen table. We have seen piecewise defined function. Now the next thing is that by graphical method, limit graphically. Observe the graph, this graph right here. Find the limit as x tends to 1 from the left. This is 1 right here. As x tends to 1 from the left, the limit is approximately 4. Remember that limit does not mean when it is 1. So it is approximately 4. So it is given here. Okay, let's see. This is the limit as x tends to 1 from the right. We are following the graph. So the value of y when x tends to 1 from the right is negative 2. So graphically, we can find limits also. And the left-hand limit is not equal to right-hand limit. Therefore, the limit of this graph does not exist. Let's quickly summarize, because now we're going to solve problems. We're going to the textbook or practice test and solve problems. Therefore, anytime I'm told to find the limit of any function, f of x as x tends to a number, maybe 1, it means that the left-hand limit and the right-hand limit must exist, and they must equal to the same thing, which means, pull it down here. Therefore, it means find the limit of that function f of x as x tends to 1 from the left, and it must be equal to the limit of the same function f of x as x tends to 1 from the right, and they must be equal to the same number. If they are the same, the limit exists, whether it is graphically, by table, or algebraically, they must be equal. Otherwise, the limit does not exist. Okay, we are going to read the summary and then go and solve problems. We can start from homework for tonight, or we can start from practice questions. So, summary of 1.1, because we are going to 1.2 quickly. 1.1. The summary of 1.1 says the limit of a function f as x approaches a is written as this. This means that the value of x approaches a, as the corresponding value of f approaches to a number. The left-hand limit means that it's coming from the left. The right-hand limit is coming from the right. Okay? If the left-hand limit and right-hand limit are not equal, then the limit does not exist. If the left-hand limit and right-hand limit are equal, then the limit exists. Okay? Okay, so when you're told to find the limit of a function, it means there is no negative sign here, a positive sign. It means check the negative and positive sign before you make a conclusion. So right now, we solve some problems. Let's go to, let's get and solve some problems. Let's go to the book. Let's get a book. Let's get our book quickly. I am going to section 1.1 of our book. I actually printed it so that you won't printed it out. I hope it opens on my, all right. And I am just quickly going to go to some questions that, all right. We have already seen this. Let's look at the numbers that, okay. And I am going to try and write on this also. Okay, I want you to see that this is a sequence. We already saw this sequence. You can do this. I think I need to quickly go to 11 because we're not going to waste time doing 1.1 today. As x approaches a number, what is the number? This is section 1.1 of the textbook. The value of this function, negative 3x, will approach 6. So you're going to ask yourself, what is this? Is a polynomial. Because it's a polynomial, I'm not going to bother about my substitution will be correct. So let me say this. If you're told to find the limit of a polynomial, just do direct substitution. Direct substitution is okay. So what I'm going to do now is, for me to, it's just like saying negative 3x. X is something, find the value of x so that my answer is equal to 6. Find the value of x so that my answer is equal to 6. That's all. What is the value of x so that my answer is equal to 6? Is it not negative 2, right? So the function they're looking for here is negative 2, the number. So it's going to be x equal to the limit as x tends to negative 2. If you plug in negative 2, it gets 6. This is your section 1.1 in the book. And so on. And I want you to know that the odd numbers have answers there. So the notation, it's about time I'll take a picture of those who showed up in class. All right. Then I'm going to go to take a picture of those who showed up so that they cannot say they were here. Okay, the notation. This notation, the limit as x approaches 2 from the left. So they want you to write it here. This notation, if you are told to write it, it's just, you're going to say the limit as x approaches 2 from the right. If it is from the right, that's a small sign. That's what it means. All right, look at the notation. The limit as x approaches 5. The limit as x approaches 5 is asking you, there is no sign here. Whenever you see this, it's asking you for both left hand and right hand limit. Find both left hand and right hand limit. Do they exist? If they exist, are they equal? If they are equal, then the limit as x tends to 5 exists. So let's go to a practice test, and then let's get a practice test as unit 2 practice tests. So I'm going to pull that unit. It's in Blackboard. Okay, everybody look. These are the questions in unit 2 practice test. As x approaches 6, the value, I'm going to write on it so I will quickly get. Okay. As x approaches 6, the value of 2x plus 7. This is a linear function. And because it's a linear function, it's a polynomial. So all I have to do is 2 multiply 6 plus 7. So I'm not worried if the limit is going to exist. The limit will exist because it's a polynomial. So the limit of a polynomial is direct substitution. Okay. And then they're asking to ask you about notation. The notation, I just wanted to know that all those things we have seen are going to be in the test, or they are going to be in any question about limit. The notation is read the limit as x approaches 2 from the right. Which one? Which one is it? I want you to choose for me. Let me see. Let me see if you are following. Oops. Let me see if we are following. Look at question number 2. From the right. Approaching 2 from the right. Which one? Is it A, B, C, D? Which one?
B.
It is B, correct. Very good. Somebody's following. Approaching 2 from the right. This is not the same. I hope you know some people choose this. A is not the same as this. This is 2 plus small sign of positive at the right. So be careful with plus 2. This is not the same as that. Okay, let's go to question number 3. This is a practice question in our book. Number 3, the notation limits of a function as x tends to 4 is read. Which one do we see? There is no sign. There is no sign. Therefore, this question is actually asking us to find 2 limits. This question is asking us to find limit of that function f of x as x tends to 4 from the left, and also find the limit of that function f of x as x tends to 4 from the right. And because we don't know what the function is, we stop here. Okay, I'm going to let you answer this question. The notation limit of f of x is read, this notation, limit from the left. I am going to let you answer these questions, and let's go to the ones we can. Okay, you know what? Let's answer one more question in 1.1 and quickly go to 1.2. I will quickly go to 1.2. Let's answer this question. Graphical limit. Question number 5, graphical limit. Use the graph f to find the given limit. When necessary, state that the limit does not exist. I'm told to find the limit as x tends to 6. People need to know that there are 2 questions here. They're asking you to find the limit as x tends to 6 from the left of that function in the graph, and the limit as x tends to 6 from the right, and see if they are equal. If they are equal, the limit exists. If they are not equal, the limit does not exist. So this question here, there are 2 questions together in one. Okay, let's go and let's look at the function. Where is x equal to 6? X equal to 6 right here. Right here. All right. So the limit as x equal to 6 from the left is almost 6. The equal to 6 from the left, this is 6 from the left, is equal to 6. That limit is equal to 6 this side. The limit as x tends to 6 from, okay, from the left is also equal to 6. Therefore, the limit exists, and that limit is 6. I want you to know, even though it's a discontinuous function, but they're not asking you anything about -6. They're asking you limit as x tends to 6. 6 is not the same as -4. So because it's a discontinuous function, you don't have any business with the discontinuity. You only asked about 6. So you focus on what the question is. But if they are actually asking us about the limits, if they are actually asking us about the limit as x tends to -4, then we know that limit from the left and limit from the right are not equal, and we can say it does not exist. But they're not asking us about limit as x tends to -4. So because some people just look at it and say, okay, they say that's a broken, it's a discontinuous function, that the limit should not exist. No, you have to look at this number here. The number we are talking about is +6. It is not at the point of discontinuity. Is there any question with this discontinuous function? Any question? Because you have to answer the question that is asked of you. You don't just look at the function and say it does not exist because it's broken. No, you have to find out where is the number that they are talking about. The number they're talking about is 6. Okay, let's go to 1.2 because we need to get there. Let's go to section 1.2. Any question? I need to go to, we are 21 now. Let me see what the question is here. Somebody asked a question. Okay. Now it's time for me to take a picture of those who came to class, so that, because usually I do take this picture in every class. The reason I do take a picture of those who showed up in classes, that people cannot say they came and I mark them absent. So I do take a picture for every class of those who showed up in class. And so whatever the reason you didn't show up in class, then I will mark you absent though. Okay, some of you who did not take the test number 1 for reasons I don't understand, that, let me say it again because almost everybody is here now, that your quarantine doesn't mean you should not take a test. So I'm going to give you a retake. I think everybody is here. I will post a retake actually this night, and I will give you only 90 minutes. You can take it from this night to tomorrow, but whenever you take it after 90 minutes, it cuts you off. And if you want to retake, even if you took the test and you want to retake, that's fine. Because, go ahead and retake it if you want to retake. But it doesn't really mean that you must make a better grade unless you studied. If your grade is better this time, I will replace this grade with the lower grade. The highest grade will be recorded. Any question about retake? Any question about retake? Section 1.2. Section 1.2 now. So I'm going to go down and pull up that PowerPoint on section 1.2. And section 1.2 is on discontinuity. Continuity and discontinuity. Differentiation. Okay, so the objective for section 1.2 I already told you that we're supposed to get to 1.3 today, but if we cannot, that's fine. We will make it up. The important thing is that you should be able to answer the questions on limits and continuity. And we really need to know what is the difference between find the continuity. Is this function discontinuous or is this function continuous? Because some people they never differentiate between find the limit and find is this function continuous. Okay, we have to be careful. Even if we don't get to 1.3, we want to make sure we know what a continuous function is. Okay, develop and use the limit principles to calculate limits. Determine whether a function is continuous at a point. Okay, so these are the limit properties. We already know this. If we are told to find the limit of a function, it means find the limit of the function to the left and to the right. If they are equal, then you say the limit exists. Okay, I'm not going to, I will not go and start. So we already talked about limits. So the properties of limit, if you're given power, you can actually say that the limit of a function to power n is the same. So if you find that limit is equal to the number to power n. I think you can read all this. I don't want to, there are some things I don't want to bother you with. We want to now, if I'm given a monomial or a polynomial, for example, let me explain this because it may not make sense to you. Suppose I'm told to find the limit of this function. Limit as this function 3x squared plus 2x as x tends to 1. I can rewrite it as limit as x tends to 1 of 3x squared plus limit as x tends to 1 of 2x. So this is addition. You can actually add limit. That's what it's trying to say. And then you apply the properties of limit. Then you check the left-hand limit and right-hand limit of each of them. Your answer will be the same if you do all of them once. If you do all of them once, it will be the same. Okay, let's quickly get to continuity and discontinuity so that limit of a quotient. The limit of a quotient is the quotient of the limits. And so that, what are they trying to say? If I'm given f of x to power gx, let me write it here. Let me use another one. Suppose I use 3x over x squared. Find the limit as x tends to 1. I can rewrite it as find the limit of the numerator as x tends to 1 of 3x divided by find the limit as x tends to 1 of the denominator x squared. So it doesn't really matter. The answer is going to be the same, provided you know that you have to find the limit to the left and limit to the right. And if limit to the left and to the right are equal, they have limit and they are going to be, your answer is going to be equal. Okay, so this is a polynomial. I already talked about polynomial. So you can do it, you can separate it into limit of x squared. That's a waste of time though. It's a waste of time, but if you're told to separate it, then you show that you know it. You can just find the limit of x squared, then find the limit of negative 3x, then find the limit of a constant. And by the way, the limit of a constant is equal to the constant. The limit of therefore limit of 7 is 7. Limit of 7 as x tends to whatever is 7. Limit of 7 as x tends to whatever it is 7. It's a constant. So don't worry about substituting anything. All right, so let's not waste time on this. This is easy because we need to get to, okay, so that is trying to break them up. You can break that up. And there are things you can read. Limit of a rational function or a radical function. You can do direct substitution. The theorem on rational function tells us that we can substitute directly. So that's what they did. So you can do direct substitution, provided you are not finding square root of a negative number. Square root of a negative number is imaginary. So if you get something like that, you say it's imaginary. All right. Okay. So these are the properties of limits we just talked about. When you go home and you read them, read those properties of limits. And we already talked about this. And I want to say it again. This is a rational function. Whenever you're given to find the limit of a rational function, please see if direct substitution will give you 0 over 0. If it gives you 0 over 0, this is a mathematical fallacy. You are not allowed to have 0 over 0, the indeterminate form. You must find the hole in the graph. So factor it out, factor the numerator, limit as x tends to -3, and then x squared minus 9 is a product of 2 squares. This is 3 here, all over x plus 3. And there is a hole in this graph, which means a common factor in the numerator and denominator. That is what causes the indeterminate form. Whenever you have the indeterminate form, there is a hole in the graph. It's always going to be a rational function. Be very careful. Don't do direct substitution. Don't come out of the class or hall where you're giving a test and so you have 0 over 0. Somebody's just going to say that you have never been in class. You have not been in a calculus class before. You can never say that your answer is 0 over 0 or limit does not exist, because it really means that you don't know you can simplify this. So you do the simplification, then take the limit by direct substitution. And then you have direct substitution here is going to give -3 minus 3, which is -6. Therefore, the limit exists, and that limit is -6. Let's continue because we need to, you see, we need to, and so, okay, you could be told to find the limit to infinity. In your homework, you will see find the limit to infinity. Listen, everybody. Anytime you're told to find the limit to infinity, you want to find the highest degree in the denominator and divide out. So the highest degree in the denominator right here is x squared. Highest degree in the denominator is x squared. All right, so I am going to divide both numerator and denominator by the highest degree in the denominator. So x squared divided by x squared in the numerator plus 4x over x squared. I'm working on the numerator right now, minus 5, I'm sorry, divided by x squared all over, then denominator, 2x squared over x squared. I'm dividing both numerator and denominator with the highest degree. So x over x squared, remember, it is highest degree in the denominator, not numerator, plus 1 over x squared. All right. Now, if I divide this out, I have 1. I have 4 over 1 here. So 1, 4 over 1, 4 over x. See what I have here. Then next time you take the limit. Limit as x tends to infinity, this is going to be a very large number. A constant divided by a very large number is 0. Just like if you divide 1 divided by 10, your answer is 0.1. If you divide 1 divided by 0.01, your answer is 0.01. So that is 100. So the higher the denominator, the lower the answer, the quotient. And so by the time you divide by 1 million, you have an insignificant number. And so it's almost equal to 0, approaching 0. And so this is going to be 0 also because you're dividing a constant by infinity squared. So you have 1 divided by infinity again, 0. 1 divided by infinity squared, 0. And so you end up having all these as zeros. So your answer is 1/2. So after some time now, you notice that you can actually eyeball an infinite limit and say the answer. You don't even have to solve it. Because the first thing you ask yourself is, what is the highest degree in the denominator? Okay, and you don't even bother yourself with all these ones. You bother yourself with this and that. X squared divided by x squared is 1, so your answer is going to be 1/2 anyway, because all these ones will be zeroing out. Let's go to the next one. Same thing here. Find the limit to infinity. It shouldn't scare you. A lot of students are always scared when they are given limit to infinity. It is the easiest question you can ever have. All you ask yourself is, what is the highest degree in the denominator? Divide all through by x cubed, and you notice that x cubed here, don't worry about these ones. X cubed divided by x cubed is 2/3. Limit is going to be 2/3 anyway, because all these ones will zero out. So when you eyeball a limit that is infinity, you will actually know it is the ratio of the highest degree in the numerator and denominator. The ratio of the highest degree in the numerator and denominator. That is the same thing as, remember when you were finding the what is it? What is it? The asymptotes. The asymptotes. You were told to find the horizontal asymptote. And so when you're looking for horizontal asymptote and you have something like this, the horizontal asymptote is the ratio of the highest degree of the numerator and denominator. But we're going to get there very soon, though. Continuity, let's define it because we don't have time anymore. We got only, do we still have time? I think I'm taking your time. I suppose this class is supposed to end. Okay, I'm sorry. I'm going to define continuity in next class. Do you have any question? I don't want to take your time so you can get to another class. I'm sorry that we had to. But anyway, we are in 1.2. We didn't get to 1.3, sorry, but we will get there very soon. So I'm going to stop sharing and I'm going to go back. Any question? Okay, we started with limits. On Tuesday we will try and we missed a day, but we will catch up. But you should be able to answer questions on 1.1 and 1.2. You should be able to answer questions on infinite limits also. It's not even difficult. You just don't have to fear it. It's not as difficult as people define it. You just have to believe you can do it. Okay, I'm going to give you a retake for those who have so many reasons not to take the test. Trust me, we're not going to be retaking every test. If you don't want to take the test, you maintain your 0 until final exam. But let's just, let me give you all the benefit of the doubt because this is first test. But just know that this was a great test. 11 people out of 22 made A's. It was a great test. I don't know what others were doing, but I'll give you a retake anyway. Question? Have a great weekend. I'm going to put it on this night, and you have till tomorrow to take it. Any other question? Any question? All right, try your homework for tonight. Try your homework for this weekend. Make sure you do them. And if you have any questions, email me. But please do the homework. Do the work. Okay. Thank you. I recorded this. Hopefully I recorded it so that you can look at it again when you get home